This video is about special trigonometric functions and what the limits are as they approach certain values. So today we're going to talk about two special situations. One is the limit as x approaches 0 of sine of x over x, and the other is the limit as x approaches 0 of cosine x minus 1 over x. Now, what we may want to notice about these situations is that both of these would result in an indeterminate form. So if I substituted 0 in for x, I would get 0 over 0 in this case. If I substitute 0 in for x here, I get 1 minus 1 over 0, which is also 0 over 0. So I end up with something that's undefined, but it's undefined with a hole. In all other situations that look like this, I would still be able to plug in x. So if I had the limit as x approaches pi halves or the limit as x approaches infinity, I could still just substitute it in and be able to figure out what's happening because I don't have an indeterminate form. But in these two particular cases, I have an indeterminate form, but with what we know now, I can't do any sort of algebraic manipulation like we did in previous examples. So we can't factor or rationalize the denominator or rationalize the numerator or something like that that allows us to simplify things and cancel things off. So we're basically going to have to figure these two out through exploration. So let's start with sine of x over x. And if we just look at it, it looks like we can plug in values everywhere except for plugging in 0. And when we plug in 0, it looks like it gets really, really close to 1. Of course, it's undefined because the numerator and denominator would both equal 0. But it looks like the value is really close to 1. And that's just based on observation, what we notice. So the limit as x approaches 0 of sine of x over x is 1. You're going to want to write that down and make sure that you're aware of that. Now, let's say I'm multiplying by certain things. So I have a times sine of bx over cx. So what happens if I change this through multiplication? So obviously, if I multiply by 2 or 3 or 4 in the numerator, that would just change what's happening. It's still undefined, but it's approaching 4 or whatever the a value is. And if I have a c in the denominator, it's just going to get divided. So notice that this one's going to approach something that looks like 1/3. Gets real close to 1/3 because I made c 3. So that's pretty obvious. And if I multiply the top by 3 and the bottom by 3, well, I would just approach 1 again. But now what happens if I change the angle? So if I multiply the angle by something. So if I multiply the angle, it actually changes what's happening as well. Now this is kind of interesting. Notice I have a is 2, b is 4, and c is 1. This looks like it approaches 8. So there's a lot of interesting stuff going on here. Basically, if we manipulate this enough, what we may start to realize is, say this is 3, this is 4. Let's make this 6. Well, it approaches 2. It appears that I can multiply A and B and then divide by C in this example. That's basically what our rule is. So the limit as x approaches 0 of A sine of bx over cx is just the product of A times B and then divided by C. So if we manipulate this with multiplication, it just ends up changing our value from 1 to A times B over C. Now, if I take my other function and I look at cosine x minus 1 over x, looks like I'm approaching 0. The value of that is undefined at 0. But this function does look like it approaches 0 as x approaches 0. So that's something that you're going to want to write down. Now, once again, what happens if I manipulate this with multiplication? Well, if I multiply the top, or I divide in the bottom, that operates exactly the way you think it would. And the angle stuff makes it repeat faster and things like that. But it doesn't appear to really have any effect on where it's going to hit at x equals 0. It looks like it's hitting an undefined value, which makes a lot of sense, because if it was undefined before and I multiply by stuff, I mean, it's still going to be undefined. And if it was 0 and I multiply by stuff, it's still probably going to be 0. So while it is undefined, the limit of this as x approaches 0 is still 0. Now, once again, all of these functions are actually undefined at x equals 0, but the limit can still be defined. So the limit is 1 in this case. It's A times B over C in this case. And it's 0 in these cases. Now, these are things that you have to memorize, but you also have to think in terms of how this is going to be something that can be used in a problem. So what would happen if we took the reciprocal of something like this? The limit as x approaches 0 of cx over A times sine of bx. That's something you may want to think about. Where can this stuff show up? What if we end up with the limit as x approaches 0 of cosine squared minus 1 over x? Well, you might have to factor the numerator and then break it into components and see what happens. So these are things that you're going to have to be able to figure out, because in problems, we're probably not just going to give you these things. We're probably going to give you things that you're going to have to manipulate and then be able to realize that these are rules that you have to use within the context of another problem.